I think there might be a bit of a time lag, actually. Um, I don't know if there is a time lag for everyone else. Okay, I'll keep going and see how it is. So, yeah, in this live, we're going to talk about dairy. And dairy is one of those food groups that people are very conflicted on. So, some people think dairy is a superfood, and other people think that it is, a toxin or a food that we're not evolved to eat. There are many kind of different opinions in the different diet spheres when it comes to dairy. So in this presentation, we're just going to discuss the pros and cons and the different types of dairy, and hopefully allow you to understand whether dairy could or should be a part of a healthy diet. So to start, just to talk about what kind of ingredients milk actually contains. So milk contains proteins, probiotics, omega-3 fats, calcium, vitamin A, B, C, D, E, magnesium, phosphorus, iron, and CLA, sorry. But despite this quite impressive nutrient profile, not all milk is actually created equally, and not everyone is equally as equipped to digest milk. So, what affects the different type of and the quality of milk? So, as with pretty much every food that we ever talk about, the most important thing to discern is actually the quality of the food and how it got from its origins to your plate. And this is usually how we can tell whether something is helpful or not when we look at how it was processed and how it was made. So, for example, if you visited an industrialized dairy operation where the cows are fed on non-organic grains and they're given growth hormones and antibiotics, you might understand that this is not the most helpful thing. Whereas some grass-fed cows that are grown and um, eating grass and walking around in the outdoors and having a varied diet of different types of plants without the intervention of antibiotics and growth hormones. These type of cows create milk with different nutrient densities and also different fat profiles. So the milk from pasture-raised cows also contains high levels of CLA and essential fatty acids. So here in the picture, you can see the difference between a grass-fed butter and and conventionally raised butter, and you can see the grass-fed butter is much darker in color. And the reason for that is because of the beta carotenes, which are present in the plants. So all plants, you might have heard of beta carotenes specifically in carrots, but they exist in all types of plants. This is why cow's butter is more yellow in the summer compared to the winter, because when there is, well, it depends on actually the hemisphere that you're in, but when there's more succulent grass for the cows to eat, then they will be consuming more beta carotene, and that beta carotene will be present in their fat, and that colors the butter yellow. So this is quite a good way of telling what the diet of the cows that you ate. And this is slightly a side note, but you can also do the same with chickens. So as you can see, this chicken on the left is a pasture-raised chicken versus an industrially raised chicken. And what you'll notice about the pasture-raised chickens is that the fat is also really yellow. So again, because they're eating grasses and grains and because they're eating bugs, they're going to have a lot more beta carotene in the diet, and then that will affect how yellow and how dark the fat is. So this is also another good way of telling when you're at the butcher the diet of the animals that you're eating. So here is a study that talks about. There are a lot of interesting studies that talk about how the diet can affect milk quality and whether the animals are foraging or whether they're conventionally raised. So this is we're talking about pasture raised versus industrially raised, but another factor to take into account is whether the milk is raw or pasteurized. So So pasteurization actually reduces lots of nutrients. So manganese, copper, iron. It also destroys a large portion of vitamin C and impairs bioavailability of B6. Pasteurization destroys some of the proteins in milk that act as cofactors for absorption. So although it might be said that milk contains these and these and these nutrients, it's unclear how many of those nutrients pasteurization actually kills and how many are still present in the milk, and able for us to and bioavailable for us to digest. So this is always important to remember, and as well as that, unpasteurized milk contains a lot of probiotics, and those probiotics will also facilitate, proper digestion, as opposed to pasteurization, which kills probiotics. So, one argument that a lot of people make when they talk about raw dairy versus pasteurized dairy is, oh, isn't it, aren't you at a higher risk of foodborne illness? And, what if you get sick from from unpasteurized dairy? And although it is true that in the past there have been many illnesses that are milk-borne, this is actually as a result of improper handling of the cows and improper unhygienic milking practices. So, if you are going to buy unpasteurized dairy, it's important to buy it from a farm or from a farmer who you really trust in terms of how he keeps the cows and how he's milking them, and just the hygiene surrounding that process, because that's the really important thing versus the milk itself actually being unhygienic or risky. So as you can see from this graph, this shows different types of foodborne illness outbreaks in different categories. So as you can see, produce is actually by far the highest when it comes to food contamination and foodborne illnesses. And dairy is actually relatively low compared to poultry, compared to seafood, compared to beef. It's really quite low. And the reason for this is because we generally consume fruit and vegetables. Well, we often consume them raw. So this means, that there's more likelihood for foodborne illness because we're not cooking and we're not killing the contaminants. Another reason is that, often with leaves or, leeks or different vegetables where the bacteria can actually get trapped in the different layers of the vegetable. And when that happens, it's harder to wash. And then because you're eating it raw, you can be exposed to um, different foodborne illnesses. Um, yeah, and generally cooking does kill a lot of bacteria. So, any foods that we cook a lot, you're less likely to experience foodborne illnesses. But dairy is very low when it comes to this. So, pasteurization. So there's different types of pasteurization, and that's why you can kind of see milk in these cardboard containers. The ultra pasteurization, where it can even stay off the shelf and it can even stay just in the grocery store. And then you can get pasteurized milk, which you'll see ordinarily find in the grocery store. And then you can have completely raw dairy, which usually is not sold in the grocery store, but you would need to approach a local farmer or just someone that that sells raw milk. So different breeds of cows and sheep and goats actually produce different types of milk. So this is another thing to take into account when you're choosing a milk that might suit you. So goat milk contains relatively less lactose than cow's milk. Buffalo milk contains more fat. Camel milk contains more vitamin C, 3 times more vitamin C actually than cow's milk. So when you're deciding which milk, to buy, you can take all of these things into account. And if you feel like you're suffering from lactose intolerance, you can choose another type of milk that has less lactose in it. So here is quite a nice infographic. It might be too small to see, but it talks about how goat milk is lower lactose, as I was saying. So sheep's milk is actually naturally homogenized. The fat, the milk solids, and the fat are naturally homogenized, so they don't separate as easy and easily as other types of milk. So this is why there are all these cheeses that you can make with sheep's milk. Camel's milk is high in vitamin C. There's also less lactose. Yak milk is really high in fat, high in protein, high in calcium. It's quite different in that sense to cow's milk. And buffalo milk, again, is high in fat, high in calcium, high in protein. It's usually a bit more expensive than the other milks because buffaloes actually don't really enjoy being milked. So it's quite hard. It's harder to obtain. And therefore, it's usually a bit more expensive. But it's also good to note that goats and sheep and yaks and camels, they're closer to the wild animal bracket, and therefore they're kind of less predisposed for industrialization. Usually, you don't have huge scale buffalo farms or goat farms in the way that you do industrialized cow dairy. So just by default of choosing one of these milks, you're probably getting a less industrialized product. So personal tolerance to dairy. So this is interesting and also quite complicated. So everyone is lactose tolerant when they're born. This is what enables us to breastfeed when we're a baby. And at some point during childhood, this function is turned off, and essentially the lactose gene is switched off. However, with the advent of dairy farming, which happened around 8,600 years ago, it happened that many people developed a genetic mutation that allowed for lactose persistence, which is the continued ability to digest milk. And this was a really helpful and accidental gene mutation. And the reason for that is because when we are able to consume dairy, we're able to consume all these great nutrients, which we spoke about earlier, when there is scarcity in the food environment. So when you're not able to farm and when you're not able to garner nutrients from crops and it's winter and all of these different things, you have a great source of high calorie and nutrient dense food. So of course, the people who developed this gene mutation were actually able to survive more than those who weren't able to digest dairy, and that is how we kind of continued this lactose persistence gene was passed down through more generations. And so this is how this kind of mutation exploded. But interestingly, it co-evolved independently across different continents. So that means that, in different continents, this gene mutation came about, and at the same time, that was happening in other places, which is quite interesting. So each human's specific ability to digest lactose depends on which parent or both parents have this, let's say, mutant, because it's a mutation chromosome. So it could be the case that one of your parents has the mutant chromosome and the other one doesn't, in which case you'll have a sort of weakened ability to digest lactose. And it could be the case that both parents have this lactose persistent gene, in which case your ability will be stronger. So it's not necessarily something that's an on and off switch that a lot of people believe. It's something that can be stronger or weaker depending on if both of your parents or if just one of them have the gene. And the other thing that will affect that, okay, so wait, look, first of all, before we go on to that, we can talk about, the different regions and the age of the gene. So in Northern Europe, the gene is 2,000 to 20,000 years old. Around 90% of the people can digest lactose. And then compared to, let's say, West Africa, where 6,000 to 7,000 years ago was the age of the gene. And you can see this kind of somewhat correlates to the age of when we domesticated cattle. But in all the West African populations, a lot smaller percentage of people have this lactose persistent gene. So here you can see in general with the world map, you can see the percentage of the population who are affected by lactose intolerance. And it's sub-Saharan Africa, South America, and then in Asia, East Asia. And generally in North America and in Northern Europe, that's where lactose intolerance is the least common. So another reason why, aside from genetics, another reason why we might struggle to digest milk is because of damaged intestinal health or things like SIBO, things like IBS. These intestinal disorders will actually impair your ability further to digest lactose. So people with gluten intolerance often have trouble with dairy because of the way in which the milk protein cross-reacts with gluten. People with SIBO will also suffer because bacteria ferments the milk and the sugar. This causes irritation. Anything that inhibits gut health, so for example, processed foods, pesticides, contaminants in water, overuse of pharmaceutical drugs, things like bacteria and yeast infections, stress. So anything that you might think would damage gut health can also affect your lactose tolerance. So what actually happens with a lot of people is that they might have, let's say, one parent with the lactose persistence gene and one without, and they have, a somewhat ability to digest lactose, but then, they take birth control pills, they're eating lots of vegetables with lots of pesticides on them, they're really, really stressed. They've taken a lot of different pharmaceutical drugs over years, they suffer from candida. Then that person who already had an impaired ability to digest dairy then has even less of an ability, and they can wrongly perceive this as just general lactose intolerance, when actually the issue is more the gut health issues that are worsening the ability to digest lactose. Um, so often what people find is that once they improve their gut health and once they, work on the infections, manage their stress better, remove processed food, people find that they're actually able to then digest lactose better. So I would definitely recommend that, if anyone feels like they might be lactose intolerant, to first of all just address your gut health on a general level before just assuming lactose intolerant and intolerance and removing an entire food group. So I think this is it for the summary of lactose intolerance. I hope that everyone learned something from it. I'm going to ask a few questions. So, what is the best type of milk to consume um, for people with type 2 diabetes? So, yeah, I would say when it comes to diabetes, having definitely having a full fat milk is important. So as we talked about in the previous slides, where we talked about the different fat quantity in camel milk or in cow's milk, so yak has particularly high fat, and so does camel. And the reason why these are better for diabetes is because fat is one of those nutrients that is satiating, and also helps um, to slow down the way that sugar is absorbed. So when you have a high fat meal, for example, people who are on the keto diet, it helps slow the absorption of sugar, and it also satiates us. So we have less cravings and less desire to eat sugar later in the day. So high fat milk is definitely better for that. There's also one thing I didn't mention, which was the type of, there's actually two different types of cow's milk. One is called A1 and one is called A2. And the A1 and A2 milks refer to the casein. So milk contains whey, I'm sure, as most of you know, and some people have issues with whey. And casein is the other type of protein in milk. And some people actually have a casein intolerance rather than a lactose intolerance. And a lot of people find that drinking milk from A2 cows, which have a different type of casein, they find it much easier to digest that type of milk. Those cows are usually found in southern France and in southern Europe, and people find those milks more digestible than other milks. So, is cow's milk safe as an alternative to breast milk? So, actually, there is a great on the Western A Price website. There's actually a great recipe for babies for a milk recipe. Let's say if you're not able to breastfeed and you're not able to give and you don't want to give formula because it contains a lot of additives and sugars and nasty ingredients that people usually don't want to feed their babies. So on the Western A Price website, there is a recipe, and it contains full fat milk. It also contains cod liver oil, I believe, maybe collagen. There's quite a few different ingredients, and I can share that link in the show notes with the recipe for milk. And I think that's a good one to follow when it comes to substituting. Well, essentially, it's a recipe for making your own baby formula if you can't breastfeed. So someone asked about turkeys. So generally, yeah, we don't drink milk from other animals. From birds. It's always from different mammals like cows, sheep, yaks, goats, these kind of animals. Horses. I think actually there are some cultures that drink horse milk. So I think maybe this is good. Does consuming soy during pregnancy cause GERD? I think that's what maybe someone asked. Yeah, I definitely usually don't recommend soy milk, or really any plant-based milk unless you have unless you definitely have lactose intolerance, which you can determine through everything that I shared. But soy, the reason why I don't recommend soy for anyone, including pregnant people, is because soy can be a phytoestrogen. It can mimic estrogen in the body, and in this way, it can disrupt hormones. It's also usually highly industrialized, so there's a lot of pesticides, herbicides, in the processing of soy. And aside from that, generally the plant-based milks are less good than traditional dairy, and the reason is because they almost always contain a lot of additives. So they usually contain things like guar gum, gellan gum, different emulsifiers that help to keep everything homogenized and not separating the fats from the liquid. They usually always contain some kind of sugar, like whether it's agave or just normal sugar. Sometimes the water that they use to mix the almonds or the oats is not super high quality. They have to homogenize it and pasteurize it to keep it in these boxes for long periods of time. Sometimes it can be the case that the nuts are actually rancid. They're not stored properly, and they can be rancid before the milk is even made. So generally, although there is this idea that plant-based milks are superior, unless you have a lactose intolerance and you don't have any accessibility to high quality pasture raised dairy, it's not the case that plant-based is a better alternative. It's actually really difficult to find a plant-based milk that contains just almonds and water, or just oats and water, for example. They're usually with all of these other additives, and they're usually also a lot more high glycemic, especially oat milk, which is, oats are pretty much just carbohydrate based. Then when you mix it with water, it's a really high glycemic drink to have. There's almost no fat that helps to balance out the glycemic nature of the drink, unlike full fat dairy. So I would definitely go for those options. Um, so someone asked, what about past Bud IGF-1 and 20 and protein allergens? Um, so yeah, so again, when people talk about, antibiotics or infections in cows that puts pus inside the blood, um, all of this is when we're talking about highly industrialized milk production, which I think everyone agrees that this is bad, and this is generally what people have against dairy. It's the industrialization of the dairy, the fact that the animals are having to be given antibiotics and hormones because they're basically sick all the time. So industrialized animals are generally always sick because they're eating foods that they're not designed for. They're eating corn, they're eating soy, their digestive tracts get inflamed, and then they get, their equivalent of leaky gut and infections, and then they have to be given drugs for that. And all of these things kind of add up to create an unhealthy cow and therefore unhealthy milk. So in this case, we're only talking about pasture-raised animals that are free range and they're eating a diet that's natural to cows, which is grass. And in that case, you don't have these problems with infections and this need to give them antibiotics. And when it comes to the protein allergies, as I was saying, so if you have an issue with casein, then you can maybe go for some type of A2 Jersey cows, which have a different casein profile that might be less allergenic. And if it's lactose specifically that you're intolerant to, you can also try things like goat or camel, which have a lower lactose amount in the milk. Or, the last thing, which is addressing your actual gut health, because it could be your gut health that's actually causing the lactose persistent gene to not function at its most optimal. Oh, yes, so turkeys, yes. Yeah, sorry about the turkey question. So turkeys are more yellow also, yes. So it's the fat that turns yellow. So butter is basically pure fat. Um, a step down. Actually, no, ghee, if you're familiar with ghee or clarified butter, that's pure fat. And then if you take one step down, that's butter, which still contains some milk proteins. And then cheese is also pretty high fat and pretty low lactose. And then yogurt is even more lactose, and things like kefir. And then milk is, of course, the most lactose. And as you go up this scale to ghee, there's less and less milk and lactose, and there's just more and more fat that's concentrated. So often people with lactose intolerance find that they can consume, certain hard cheeses and also clarified butter, which is almost pure fat. And those type of fats will be really yellow and dark in the case of the animal being pasture raised. So it's the same with turkeys. It's the same with the fat of cows. It's the same with the butter of cows. It's just a good way in general to check out how industrialized the animals are. Okay, so I think that's it for the questions. What I'm going to do is link the recipe for the breast milk alternative, the formula alternative, in the chat from the Weston Price website. And yeah, thank you for listening. And if anyone is interested in the Phoenix Protocol group coaching program, you can scan this QR code here. And every week we go through different content related to things like sleep optimization, stress regulation, diet, supplements, and prescriptions to address long COVID. And at the end of every week, we have a call at 1 p.m. Eastern Standard Time. And we talk about the content that we've gone through in the course, and everyone has a chance to ask questions. And then we do some follow-up emails in the interim during the week. So if anyone would kind of like to deepen their knowledge on any of these subjects, the Phoenix Protocol is a good place to start. So thank you very much for listening, and hope to see you next week. Bye.